Okay, we need to talk about determinants of matrices. Now, a determinant is just a number, okay? So it doesn't come out to be another matrix or anything like that, so it's always just a number. And it has lots of uses when you're dealing with matrices, and we'll get to the uses once we learn how to figure out what a determinant is. So the first thing you need to know, though, is that the matrix must be square. If it's not square, it won't have a determinant, okay? So if I ask you to find the determinant of a 2 by 3, then don't do it, okay? So it has to be a square matrix, so it has to be a 2 by 2, or a 3 by 3, or a 4 by 4. You get it, right? So square matrix, where the number of rows is equal to the number of columns. Now, let's start with, how do you denote? What's the notation for determinants? You can say DET, that's an easy one, the determinant of a matrix A, or you can do something that looks like an absolute value sign, okay, and that would also mean determinant of matrix A. So that's our notation. Let's start with a 2 by 2 matrix. So a 2 by 2 is easy, okay, because there's a formula and we're just going to follow the formula. So if I say A is equal to, and let's just give little labels, A, B, C, D, okay? Then I'm simply going to call the determinant of A is equal to the number given by multiply A times D minus the product of B times C. And whatever that number is your determinant. So, one way to think about this, nice and nice, is to multiply this diagonal and then subtract this diagonal, okay? So let's go try one. Okay, here's a matrix A is equal to 2, negative 3, 1, and 2. And if I want to find the determinant of A, then I'm going to multiply these two together, 2 times 2, minus what happens when I multiply these two together. So negative 3 times 1, and get 4 plus 3, the determinant of A is 7. Okay? So let me give you one to try. That's a 2 by 2 matrix. Let's say we have A is equal to 2, 1, 4, 2, and I'm going to let you try this one. Find the determinant. Okay, how's it going? Okay, I'm going to put my answer up here. It's pretty easy to do. I'm going to get the determinant of A is 4, minus 4, 0. I got 0. Okay, how did I do that if you want to see it? I took 2 times 2 and got 4, minus, take 1 times 4 and get 4, and that's how I got my 0. Alright, so let's move on to a 3 by 3. Okay, in general, if you have a matrix A, and you want to find the determinant, and it is a 3 by 3, and then you're going to use an element, the A11 element, times what we call a cofactor for that element. Okay, we'll call the cofactor C11. Okay, it's just a number. I don't know why we use a capital letter for it, but it's not a matrix, it's just a number. Okay, and this right here is called a cofactor, and it's just a number. Alright, then, hey Lou.
Hey.
Okay, good news is my new computer's here. So I got to finish though this how to find a determinant, because I wasn't done with that first equation. I did that for the first A11 element, but I have to do that for the rest of the row. Okay, so I've picked the first row, and I'm going to keep going with that first row, but now move to the second column and find. Alright, let me try to pick up where I was interrupted. I wanted to finish this equation. I was working on the first row of A, and I'm only going to pick one row. Okay, so I've chosen the first row, and I did the first element in the first row, so first column, and then I'm going to do the same thing with that same first row, but now I'm going to go second columns. So find the element A12, first row, second column, and find its cofactor. And then do the same thing with that same first row, but now the third column, element and then find the cofactor that goes with that. So a cofactor, remember, is just a number. Okay, remember that? How do you find a cofactor? The cofactor for any position is just the sign for that position. So it can be a positive or a negative. That's what I mean by sign. Times what we're going to call a minor, m for that position. So you have to have the ij, little subscript, so you know the minor for the 1, 1 position or the minor for the 1, 2 position. Okay, so let's talk about each one of those things. The sign comes from a sign pattern matrix, okay, where it's just composed of plus, minus, plus, minus, plus, minus, plus, minus, plus. So that is the sign pattern for a 3 by 3. And all you have to do is memorize that, okay? So for example, if I want to know what's the sign for the 1, 3, okay, cofactor, the sign in the first row, third column, forget I circled that one, because now I'm going to go first row, third column, it's a plus. Okay, so I'll put a plus in front of the number. Alright. Okay, or it's really a plus 1 times the number. Okay, so basically you're not changing the number if it's plus. If it's a minus for the sign pattern, then you're going to take an opposite. It's as simple as that. Minus 1 times whatever the number you get for the minor. Okay, so now we have to go figure out how to find minors. Okay? Okay, to find a minor, okay, for a particular location, what you do is you delete that row and you delete that column. Remember, we always do rows, then columns, and boy oh boy, we just keep doing this. Rows, ith row, and then the jth column. Okay? Once you've deleted that row and that column, then you find the determinant of the remaining matrix. Okay? So I think we obviously need to do an example here. So, example. Let's have a matrix. It's a 3 by 3. So here's 0, 2, 1, 3, negative 1, 2, and 4, 0, 1. That is my 3 by 3 matrix. I want to find M11. Oops, there's no dot on a 1. But okay, let's find M11. Okay, what we're going to do is delete the first row. Delete the first column. The remaining matrix will find the determinant of negative 1, 2, 0, and 1. See this right here? So here's the remaining matrix, and taking a determinant of it, so it looks like that absolute value symbol. Alright, so now I have to find that determinant, and I'm going to get, on the diagonal, minus 1 times minus 1 is minus 1, minus, on the diagonal this way, 0. So M11 is equal to a negative 1. If you remember, my sign pattern was plus, minus, plus, minus, plus, minus, plus, minus, plus. So the sign pattern for 1, 1 is right here. So it means I don't change the sign. I multiply by a plus 1, and I get C11 is also a negative 1. So it's going to happen. Either you change the sign or you don't change the sign of the minor in order to get to the cofactor. So I found my first cofactor. Okay? Great. Okay, I'm going to do one more with you, and then I'm going to ask you to do one on your own. So this time we're trying to find the minor 1, 2. So delete the first row, delete the second column, find the determinant of the remaining matrix. So the remaining matrix is 3, 2, 4, 1. So I need to find that determinant, and that will give me M12. So that determinant is 3 minus 8, or a negative 5. So I found M12. And if you remember the sign pattern, okay, there's our sign pattern. So now I'm in the 1, 2, which is right here. Ah, look at that, it's a negative, so I'm going to have to change the sign to get to C12, which will then be plus 5. Okay? So the sign pattern's not telling you is the number positive or is the number negative. It's just saying, should I change the sign of the minor in order to find the sign of the cofactor? So hopefully that's clear now. I found M12. as well as M11, and I'm going to ask you to find M13 next. Yeah, go ahead and find M13. I'm going to pause it and come back with the answer, so you should too. Okay, so I worked it out in black. Removing the first row, removing the third column, leaves me with 3, -1, 4, and 0. So finding that determinant by multiplying diagonals and subtracting, I get M13 is 4. Looking at the sign pattern for 1, 3, it's plus, so I don't change the sign, and I end up with a cofactor also 4. Okay, so actually I'm finally ready. I've got all the pieces I need to put together the determinant of the entire 3x3 matrix A. So let's do that on the next slide. Okay, recap. I rewrote my matrix A. I wrote down what all my cofactors were that I found so far. And remember, I only need to do cofactors for one row. Okay? Now, I need to remember what the whole determinant of A formula was. I'll remind you it's A11, C11, A12, C12, and A13, C13. So let's start plugging and chugging. All right, A11, that's the element in the first row, first column, right there. That's 0 times a -1. Who cares what it's times? It's got to be 0. So, nice that we have a 0 there. All right, A12, that's this one. First row, second column number is a 2, and C12 was 5. A13, the 1, times its cofactor, C13 is 4. So I get 0 plus 10 plus 4. The determinant of A, there we go, after all of that. What am I on here? The 6th slide. 14 is the answer. So I found the determinant of that matrix. So let me just talk for just a minute about that importance of a 0. You actually have a choice of which row to expand on, okay? And because that 0 makes everything so nice, I didn't even have to figure out what C11 was, right? It didn't matter what it was. So I could save myself a little work. So it is nice when you're choosing which row to use to choose a row with a 0 in it. So I could have chosen the third row as well and had the same kind of answer. All right, so let's try another one on your part. Okay, I'm going to find the determinant of A one more time as an example. So if you want to follow along, the first thing to do is decide which row that you want to expand on, and I'm going to choose row 2 because it has a 0 on there. So the first thing I'm going to do is find C21. Okay, so using the second row, now I'll start with the first column. So I'll be eliminating that second row, and for the first one I'll be eliminating the first column. So I have to find, let me find M21 first. It's going to be the determinant of the matrix that's left. So I'm taking the determinant of 9, 4, 7, -6. And that, of course, is minus 54, minus 28, and get 8. -82. If I remember my sign pattern, it's plus, minus, plus, minus, plus, minus, plus, minus, plus. So for this one, I have a minus. I have to change the sign. C21 is equal to the opposite of a -82, so it's a plus 82. All right, let's find C22. So first I'll find M22 is equal to the determinant of course I'm removing the second row and the second column. What's left is -2, 4, 6, -6. And you get, when you multiply on this diagonal, you get 12, minus the other diagonal, 24, so you get -12. This sign pattern is a positive, so I do not change it. Okay, so I had a slight audio malfunction. Let me finish. I think we just found C22 is -12. Now I went through and I did the calculation for C23 forgetting that I didn't need it at all. Okay, so I crossed it out. You don't need C23 because A23 is a 0. See this 0 up here in the very front thing? I can do an arrow. Ah, look at that. See that 0? So I don't need to find C23 because 0 times it will still be 0. All right, so cross out the green stuff. So then we're just going to go down to finding the determinant. So I'll need the element A21. So the sort of, can I move that arrow? Ha, ha. I can move the arrow. The first, the second row, first column element. Okay, so A21 is a 7. So that's what I've got here. Oh, it's hard to do arrows and pointing here. Okay, so I got this 7 down here times its cofactor C21, 82, plus take the next, plus take your next one, we can do it that way, take the -6, that's your A22, -6, times its cofactor, -12. Okay, so I'm down here, and I don't need to do the third one because it's 0, and calculating that I get 236, if I did that all right in my head. Alright, so that's it.